This chapter is about the interior of the Earth. When we say interior, we are talking about the inside of Earth. So, if you are familiar with this diagram, the different layers of Earth, that is the core, mantle, and crust, these all together make the interior of the Earth. And there is a constant change that is going on inside the Earth. Knowing those changes requires us to understand the interior of the Earth. That is what we are going to learn in this chapter. The landscape that we see around us is a result of a constant endogenous and exogenous processes. So endogenous means internal and exogenous is external. Now internal processes such as volcanic activities, folding of the crust and faulting due to plate tectonic activities. So all these processes change the landscape and they are collectively known as endogenous processes. Now, exogenous process are those activities like weathering, erosion, transportation, deposition, denudation. All these acts causes changes to the outer physical shape of a landscape. The main reason it is important to know about the interior of the Earth is due to the fact that human settlement is largely based on physiographic conditions of a region. That's why you will see in plain areas the population is more compared to hilly and mountainous region. Now, we have seen a lot of times due to natural calamities like flood, landslide, there's a huge risk towards human life as well as properties. And if we know why the earth shakes or how a tsunami wave is generated, that will help us in creating necessary mechanisms that will protect us from any of such natural calamities. Again, going back to this diagram about different layers of earth, scientists have gathered enough information and various characteristics about each of these layers. So this chapter will basically help us know more about these layers. Let's read some information about the interior of our Earth. The Earth's radius is 6,370 km, and no one can reach the center of the Earth. And it is obvious as to why we cannot. So in that case, we only have two ways of collecting information about the interior of our Earth. And that is through direct observations and analysis of materials. First, let's know about some direct sources. Under direct sources, we have rocks that are like a strong evidence which we can use to know the interior of the Earth. The rocks that we see on the surface or the rocks we get from mining areas, they all speak something about the interior of the Earth. But it is generally said that if we can get some rocks that are direct from the interior, we have better information that will lead us somewhere. Because the surface rocks undergo constant weathering due to rain and wind, hence, it is not as good as an interior rock from a mine. That's why we have many scientific projects around the world that penetrate into deeper depth to explore the conditions. There are projects like Deep Ocean Drilling Project and Integrated Ocean Drilling Project to gather large volume of information and analyze materials for understanding the interior of Earth. Just a quick information here. The deepest drill is at Kola, which is in Arctic Ocean, and it has so far reached a depth of 12 km. The crust, that is the upper layer of the Earth, is itself 30 km deep from the continent, not from the ocean bed. It is that thick. So 12 km is just half of it, yet it has been the deepest drill till date. This is something to think about. So this was the drill part for gathering information. Another way is to analyze the material that comes out automatically from the interior. I'm referring to the volcanic activities. Volcanic eruption forms another source of obtaining direct information. So whenever there is any volcanic eruption, a sample of the magma is tested around the globe by scientists to determine its components. However, it is difficult to assume the depth of the source of such magma, meaning from where this magma has evolved. Is it right from the core or is it somewhere in between the Earth's layers? So there are some limitation when the quest of knowledge is dependent on direct sources. However, it is far better than going in person inside the Earth, which can otherwise be fatal. Now let's read about some indirect sources that gives us information about the interior. So the temperature and pressure increases as we go from the surface towards the interior in deeper depths. Now this information was observed through mining activities. Another very important information we know is that the density of the material also increases with depth. Now that we have all these facts, scientists have developed an estimation as to what the temperature, pressure, and density of each layer will be with respect to the total thickness of the Earth. Again, these are estimation, that is approximate values. So here you see a lot of mathematical concept comes into play. That's why it is referred to as indirect sources. Another source of information are the meteors. Have you ever heard of meteor shower? That's the time when meteors reach the Earth. Since they are not part of Earth, you must realize that they are solid bodies developed out of material similar to that of Earth. Hence, this becomes yet another source of information about the interior of the Earth. Then other indirect sources include gravitation, magnetic field, and seismic activity. So gravitation force is not the same at different latitudes. It is greater near the poles and less at the equator. And the reason is because the Earth is not a perfect sphere. It is bulged at its center. So its distance from the center at the equator is comparatively more than the poles. The gravity keeps on changing as we move from one place to another, but it is maximum at the place where it is nearer to the center. As a result, the gravity is more at the poles and least at the equator. Now, this change in gravity reading is called gravity anomaly. The gravity values also differ according to the mass of material. And we know that materials are unevenly distributed on Earth. Moments back, I told you that gravity is more at the poles than at equator. Therefore, we can say that the materials found at the pole have higher mass compared to the materials found at equator. And that's why you will see North and South Pole are rich in natural resources. The next topic is about earthquake, and I've made a separate video on it. I'll link the video in the description and you can have a look at it. So now we are going to move on to the topic types of earthquake. The first one is a common one and is known as tectonic earthquakes. Whenever you hear the word tectonic, we are referring to the breaking of the crust part of the Earth's surface. So the breaking of the crust part is due to sliding of rocks that creates a fault, and that's what the entire tectonic earthquake is all about. The second one is recognized as volcanic tectonic earthquake. These are confined to areas of active volcanoes. Now you see this word tectonic again associated with volcano. So you know that volcanoes are like a ventilator of the Earth's surface from where the magma comes out. Whenever the magma comes out of the volcano,